A confirmation about the audio, please, guys. If the audio is clear and available. Thank you. So, hello, a very warm good evening to all of you, and welcome to Baiju's Exam Prep IAS. Welcome to another session of geography, where today we shall be proceeding ahead with the discussion of physiography that we had left off on Saturday. So, on Saturday, while we had initiated the discussion for the portion of Indian geography, we looked at some of the basic features of the mountains. Initially, we had taken a look at the portion of the location and how is it that the location of the country provides India with a unique kind of a geostrategic and geopolitical advantage. Why is it that India is referred to as a subcontinent? And what are the advantages owing to the location atop the Indian Ocean that India basically can end up exploiting? We also looked at the concept of choke points, where we observed the choke point to be imposed around the Strait of Malacca can impose a significant economic cost on, let's suppose, the Chinese trade and so on. So, all those factors we looked at in detail. We also observed the formation of the three ranges previously itself. So, here we discussed why is it that the region of Himalayas experience so frequent earthquakes. There we noticed that the earthquakes they occur across the thrust faults, and there also we took note of the fact that across which thrust fault do these present earthquakes they do happen. For example, the earthquake in Nepal was something which happened due to movement across the MBT. The earthquakes in Assam, the earthquakes in the region of the northern part of the country, they happen because of any kind of movement which happens across HFF. So these are the factors that we had discussed. And then we moved ahead to discuss about the formation of dunes and duars, that these depositional features which are formed between the mountains, they are known as dunes and duars. So they are formed as the folding happens and there is, let's suppose, deposition by a river or any kind of a stream whose flow has gotten disturbed, has gotten blocked. So that is where the water accumulates, depositing significant amount of material so that it behaves like a plain like surface. And that is what is known as a dune in the region of Western Himalayas and is known as a duar in the region of Eastern Himalayas. Today, we initiate the discussion from the formation of chos or khos, howsoever you pronounce it. So basically, what are these? So here you have to understand that when we talk about the region of the Himalayas, they represent a hogback topography. That is what we have discussed. Now, which of the slopes of the Himalayas are much steeper, the southern or the northern? Which of the slopes are steeper in the case of Himalayas? Very good. It is the southern. So the southern slopes are very steep. It is the northern slope which is gentle. So this will always be, in a way, somewhat like this. This is a kind of what we refer to as the hogback topography, isn't it? Hogback topography. Now here, it will have a distinct southern slope and a distinct northern slope as well. So, when we talk about the monsoonal period, during the monsoonal period, during the monsoons, the winds as they are going to come towards this southern slope, they are going to experience almost a vertical uplift. Significantly vertical uplift of air mass will happen, of moist air will happen, which will lead to the formation of very, very dense clouds and cause substantial amount of rainfall across the southern slope. Now, this significant amount of rainfall across the southern slope, that in itself induces many of the various changes. So here, when we talk about the southern slope, when we talk about the region of the southern slope, basically here, think about it, that you have immense amount of rainfall which is caused, very high amount of rainfall which is caused across the southern slope. Let's suppose this is the cross-sectional view of the southern slope here. Okay, this is your southern slope. Now what will happen? In the mountainous area, if you have sudden occurrence of very high amount of rainfall, you will find various different streams, seasonal streams, which will start to flow. Various different types of seasonal streams which will start to flow. Now, as these streams they start to flow basically from various ends, random temporary streams from random directions will start flowing down the slope. Now, as a result of that, they will be eroding the southern slope of any topsoil, etc., which will be present. The southern slope will be eroded of all of them because of these network of small seasonal streams. Network of small seasonal streams. Okay, so across the southern slope, you will observe a distinct amount of these streams moving in a random manner, accumulating all the excess water. They will start flowing down these slopes. Now, as they do start flowing down the slopes here, they will erode this area, right? They will form these ridges. They will form this undulating, a kind of a varying topographical platform in this area. So that is what we refer to as chos. So the southern slope of these ranges, particularly in the region of Punjab and Himachal Himalayas, it is formed in the slopes across Punjab and Himachal Himalayas. Formed in the region of Punjab and Himachal Himalayas. That is where this will be very prominent a feature. So the southern slope are completely devoid of forest cover in the region of Punjab and Himachal Pradesh and are highly dissected by several seasonal streams locally called chos. These are formed during rainy season due to excess rainfall across the southern slope and huge amount of erosional power that these streams will have. Formed due to excessive rains during the monsoon months. Okay. Excessive rains observed during the monsoon months, and the streams are highly seasonal in nature. Okay. The streams becoming very highly seasonal in nature, and they carry out a series of erosional structures, erosional gullies, etc. in that area. That is what is referred to as course or chores here. Okay. Then we come across another depositional feature. So, when we talk about chores, these are erosional features. When we talk about depositional features, that there is similar to the occurrence or similar to the process of formation of dunes and duars, you also will come across the formation of karevas. Karevas are also temporary depositional features which are created. These are also depositional in nature, but this has been formed in the region of Jammu and Kashmir. So, depositional feature formed in the region of Jammu and Kashmir. Now, where are these depositional features created? And if the depositional features are created in the same way as the dunes and duars, why don't we call them dunes and duars? Why do we call them karevas? Because in the case of dunes and duars, we observe that that deposition happens in a very small isolated region, maybe a hill and a mountain on one side and another hill coming up on the other side. In between them, you have that kind of a depositional feature which gets created. Okay, so that is where in between these mountains you have that kind of a depositional feature which gets created. Now, when we talk about these karevas here, in this, the deposition is created across a very wide area. Okay, here the deposition has been created over an area of around 5,000 square kilometer. So that is huge. So how did this deposition got formed, or how is it that this depositional feature was created? So this got created, this deposition happened to exists between the Pir Panjal ranges to the south and Zaskar and Great Himalayas to the north. Himalayas to the north. So in between these two, you have the deposition which has been created. So let's suppose you have a mountain here in the formation or in the form of, let's suppose, the Zaskar ranges. Now, various Zaskar and the Great Himalayas, which will obviously be to the northernmost side, there you have had many different streams and rivers which were draining to the south. Now, still in that point of time, after a few million years, you also had the formation of the mid Himalayas. And here you had the formation of, in the region of Jammu Kashmir, you had the formation of the Pir Panjal ranges. The mighty Pir Panjal started getting folded. Now, as the Pir Panjal ranges, they get folded. They would accumulate the water in between them. All that water would be accumulated in between them here. Okay. Now, as they would accumulate that water, the water, it is said that water accumulated across the entire area of close to around 5,000 square kilometer is the aerial spread where water finally did accumulate. 5,000 square meter or 5,000 square kilometer of the area was where this water got accumulated. So that led to the formation of a very large lake of sorts. This entire region was where the water eventually got accumulated. Now, eventually, this water would keep on accumulating, aided by the folding of the Pir Panjal to the south. You had Pir Panjal to the south. And this water would bring very fertile deposits along with them, because these water would be coming from the top of the mountains. So they would form very fertile deposits. Deposits which could be categorized into the category of lacustrine deposits. Deposits created due to a large lake, they are categorized as lacustrine deposits. Large, fertile, lacustrine deposits. Lacustrine here refers to deposits created in a lake. Eventually, as the water level eventually increased, then water found certain exit paths here and there. Because always understand, in the case of dunes and dwars also we had discussed, that if the mountain, and if you consider a mountain or any kind of a fold, at the bottom or at the base, the water can accumulate. But as you come closer to the conical top, the water will start to overflow from the surroundings areas and from the sides. So the water would begin to flow out. So as that water would begin to flow out, then it is said that from the region of Baramulla Gorge, you would have heard about the name Baramulla, very important town in the region of Jammu Kashmir, the hub of ancient trade route, which would, even the old Mughal road would pass through the region of Baramulla. So there, from the region of Baramulla Gorge, it is said that all the water eventually exited. And when the water exited, all this excess water did exit. All this excess water exit, evacuate from the Baramulla Gorge, leaving behind the deposits. Leaving behind the deposits. And these deposits, they are known as karevas. These are the deposits which are known as karevas. So the water would exit. So water, when it would exit, it would leave behind these. Okay. So these deposits, they would be known as karevas. So naturally, karevas would be very fertile, very fertile. And when these are very fertile, so there they support crops like saffron, one of the costliest spices in the world, saffron, fruit orchards, etc. So basically, when we talk about the region of Karevas, there, how they are being created. So you had many small streams and rivers which would originate from the region of the Great Himalayas and the Zaskar Range, and then these would flow to the south. Eventually, you had the folding of the Pir Panjal range, and that Pir Panjal offered a kind of an obstruction whereby that water could not flow anymore. So it kept on getting accumulated and formed a very large lake spanning an area close to around 5,000 square kilometers. So that is a very large area we are talking about. Now, eventually, when the water level increased, eventually from a region of the Baramulla Gorge, all that excess water did evacuate, leaving behind these fertile lacustrine deposits. They are known as lacustrine deposits because all that stream water, river water which was coming in, it would form a very large endless lake. And hence, the deposits created in that lake are referred to as lacustrine deposits. Eventually, when the water would exit, it would leave behind those deposits, and that is what would be referred to as karevas. These karevas are very fertile and are one of the sources of very rich and bountiful agricultural returns that you observe in the region of Jammu Kashmir. Okay? No, Bhotias don't live here, Mega. No. Bakarwal and Gujars you will still find. Bhotias don't live here. Biswajit, what are the concepts that you have not been able to cover in the online sessions? Please let me know. Which are those particular concepts which you have, unless until you are talking about the geographical rock formations, etc., that is Aryan rock, Dharwadian rock. Other than that, which are the portions that you feel have not been covered? Please feel free. Dunes are by river and Karevas are by lake depositions? No, Ankush, that is what I have clarified here. Dunes are also by rivers and streams. Karevas are also by rivers and streams. But the why we refer to as the lacustrine deposits here is because here these rivers and streams ended up forming a very large lake. That is why it is referred to as lacustrine deposit. When you have a large lake, at the bottom of the lake, will you find some deposits to exist? From the nearby areas, let's suppose there is excess rainfall, it will drain that water and sediment into the lake. So will you expect those particular deposits to exist? Isn't it? So when you expect those deposits, so those deposits which are formed in the lake, that is a lacustrine deposit. Okay, Santosh? That is what we refer to as lacustrine deposit. Why we observe this only in Jammu Kashmir? That is where it was formed. That is where this process actually happened. That is why you observe this kind of a large deposit to happen in the region of Jammu Kashmir. In the other areas of Western and Eastern Himalayas, you basically had small deposits in between the hills, and that is what would be referred to as dunes and duars. Biswajit, I would still want you to let me know which are the portions that you feel have not been covered in the online sessions. We shall take care of that. So please do let me know. Now, in the region of the Himalayas, at a greater height, beyond 3,000, 3,500 meters, you will find the predominance of grasses. Trees cannot grow beyond a particular height, or trees beyond a particular altitude, you won't find the growth of trees. right? So these particular mountains, whenever we talk about the mountains, beyond a particular height, you will only find the presence of grasses or grasslands. During the summer months, when the snow and the ice will melt, the grasses will grow. And then during the winter months, basically, you will observe the entire region to be covered in snow again. So these seasonal grasslands which grow, these seasonal grasslands, they are known as bugyals. So bugyals are your seasonal summer grasslands, which will get created in the higher altitude beyond 3000 meters, that too only during the summer season, not at lower heights. Why? Because at lower heights the temperature is higher enough, the rainfall is sufficient enough. So as a consequence of that, there you will find the growth of trees, various different types of trees, deciduous, in certain areas even evergreen trees would be found to be growing in this area. But when you talk about the higher altitude, there you will find the presence of these seasonal grasses. So these grasses are basically used by the nomadic community in quite significant proportion, where they would use these grasses in order to feed their animals or the cattle that they are having. So you have the Gujars, the Bakarwals, the Bhotias, all of them. They would regularly go up the mountains along with all the cattle, all the sheep, the goats, etc., that they have during the summer months in order to search for ideal pasture land where you have availability of green grasses to consume. So they would all go up the mountain. They would consume that. And then again, during the winter months, they would retreat down the slope. So that is always going to be there. So that seasonal migration by the pastoralists in order to find greener pasture for their animals, that is what is also referred to as transhumanes. That is what is also known as transhumanes. Seasonal migration by pastoralists. That is what we refer to as transhumans. So basically, it is carried out by various different types of tribes, various different tribal communities. So you have the Gujars, Bakarwals, Bhotias, etc. Carry out transhumans. Which type of soil is there in the Karevas? It will be alluvial soil, very fertile and fine sedimented alluvial silt deposits it will be, but alluvial soil in that category. And grazing of, yes, in Uttarakhand area, like Joshimath sector has mature mountain, then areas of Pithoragarh. Shiv, I hope we have discussed that Joshimath is not a mountain. Joshimath is not situated on a mountain. Joshimath, what we have discussed even in the case of weathering and the case of mass movement, I hope few of you at least would recall, Joshimath lies on the deposits of landslides, the older deposits of landslides which have happened. So on those deposits of landslides, unconsolidated sediments, you have the region of Joshimath, which is situated. Okay, so it is not on the mountain, but having said that, it is not as if the entire mountain formation would happen at the same time. Always understand that. Always get that clarity that in between the Great Himalayas and the Middle Himalayas, there was a time span of 20 million years. And it was not the case that all the mountains of the Great Himalayas will be folded, would have been folded at the same time. When we are talking about the fourth range of the Himalayas, do you think the entire region of northern Uttar Pradesh, Bihar, etc., suddenly they will get folded? No. You will have some folds in certain isolated areas. As the push continues to happen, maybe other folds will appear in certain other areas. And that is how these folds continue to happen. So, obviously, there is going to be a time difference. And depending upon whether that folding in a particular region is still happening or not, or whether it has already happened, that is how you get to understand the stability of the rock system, which rocks have actually folded up. That is also, for example, in the Pir Panjal, you have the evidences of certain igneous rocks which have been folded up. Okay. Yes, Pio, that is correct. Why they return to the valleys in winter? It can be dangerous as valleys are much more colder. Broader valleys we are talking about with air drainage, not the narrow valleys. Okay. Biswajit, my dear friend, see, I'm not going to go for the slide by slide comparison, but for example, when you talk about law of eccentricity, what is covered in Milankovitch cycle, why the law of eccentricity, obliquity, etc., has not been covered in the session is primarily because this has never been asked in the GS paper. Never. In GS geography, this has never been asked about the entirety of the Milankovitch cycle. Having said that, if you would have read the portion of additional reading materials, we have covered it under the portion of the additional reading materials. Just take a look at it. That is why it is additional reading. Most of you take the additional reading material as a thing that it will be a compilation of this. So that is where we have included the portion of Milankovitch cycle if you are interested enough. And in the classes, we have had few of the candidates who had picked up questions from that why this ice age comes, etc. We have talked about it. But as a separate topic, Milankovitch cycle is not relevant for your general studies. And secondly, the behavior of insolation in atmosphere and types of solar rays, as in the X rays, UV rays, etc. Again, understand that is something that you are going to cover in the portion of science and tech. So, there is no reason to do that double work. Double effort is not at all required. Shadow zones have been asked. So, always see, understand, simplest of the things. Please don't have a blind faith or a blind trust on anybody. Follow the concepts, understand the concepts, whatever somebody has to offer, understand the concepts as deeply as you can, and then analyze with the help of the previous year questions in the mains or in the prelims. Now, in the prelims, the problem is many of the questions are very factual in nature. So that might have come in 2017. After that, it has not come. So you cannot judge on mains question. I will still hold a guarantee that out of 105 marks for the mains examination, if you would have been thorough with the class discussion, not only reading the annotations of the PPT, with the discussions that we have had in the sessions, the various to and fro exchange of ideas that we have had in the session, I will still guarantee that out of the 105 marks, easily 95, 90 to 95 is the direct. That's something you will find to be asked from the class. So think about it, from 95, you can easily attain around 65 or 70 if you are writing good answers. So that is monumental task. After that, you are free to follow whichever source that you want. Always judge anything based upon these parameters. Okay. From where we get the year-long timetable, write to us at IS Live, Payal. You'll get that. You'll get the year-long timetable. Yes, Prem. In January, it was in news that Joshimath is sinking. That is why we discussed in significant detail about why Joshimath is sinking. You can take a look at the Module 5 discussions. You will get an idea about that. Okay. Why Himalaya between Kali River is discontinuous? Not the entirety of the Himalaya, Shivaliks are discontinuous. And that is because wherever a river moves, there, if a large river is moving, so there the folding does not happen to that extent. That is why even between Tista and Raidak, in the east, there also the Shivaliks are discontinuous. Okay, so because of the movement of that river and the flow of that river, it did not allow the folding to happen. That is why. Okay. Payal, write to us at IES Live about the year-long timetable. We will get that generated. We'll give it to you. Okay. Any other areas? Biswajit, do let me know. So that is basically the case of the features which get created in the region of the Himalayas. Now, when we talk about the region of the Himalayas, in the eastern portion, across the eastern frontier, you will find the presence of fold mountains across the eastern portion and the eastern frontier as well. You have the Patkai Bum, you have the Naga Hills, you have the Mizo or the Lushai Hills. Now, these are also fold mountain systems. Fold mountain systems because on the side of Myanmar, you will find the continuation in the form of Arakan Yoma, Pegu Yoma mountain ranges. That is on the side of Myanmar. Okay. Now, here, these are not very high. These altitude is not very high in this area. Altitude is mediocre and densely covered in forest because of very high amount of rainfall observed in this area. So here you will find that the Shivaliks, they have various different ranges based upon the name of the local tribes in this region. That is why here you will find the Shivaliks, as we have discussed earlier also, to be named as Dafla, Miri, Mishmi, Abor. These are basically the names given to the Shivalik. It is in the east where the Himalayas, from the region of Namcha Barwa, that is where the Himalayas will take a sudden syntaxial bend. Okay. Garo, Khasi, and Jayantia, they are not considered to be a part of the Himalayas. They are still very much considered to be a part of the Peninsula Plateau. Okay. So these are your folds, and this is the region of the Peninsula Plateau, which is an extended form of the Peninsula Plateau. Now, after this, we come to the portion of the northern plains. Now, the northern plains, they represent the Indo-Gangetic plains all along with the way of the Brahmaputra plains also. They represent some of the most fertile deposits on the land over a large area. Now, for a long period of time, everybody knows that these plains have been created as a result of the deposits carried out by the Indo-Gangetic and Brahmaputra rivers, basically river Indus and its tributaries, Ganga and its tributaries, and Brahmaputra and its tributaries. They are primarily responsible for the entire deposition which has happened in the region of the northern plains. But if you apply your logic, let's suppose from a mountain area, from the region of the mountain area, if let's suppose there is flow of that river water. Now, as that river water tends to flow, it will carry out the deposits. The deposits will be given in the vicinity. In the surrounding areas, you will have all these deposits, isn't it? Now, think about it. Over a period of time, these deposits would be so significant, they will form an uphill kind of a portion. But the northern plains are close to the sea level. How is it possible that even after so much amount of deposit, they are now at the region of the sea level, maybe 100 meters above sea or 100 feet above sea level, but not beyond that? Why is it so? So for this, various geographers had given various different theories. The concept of four deep provided by Edward Seuss, that stands the test of time. And that basically holds correct in terms of the entire formation. So what is it that Edward Seuss had said? So here, Edward Seuss. Yes, Vibhu, correct. Provided the concept of four deep. Now, what is this four deep? So basically, what he said was that whenever there is compression which happens, whenever, so a compression will not only lead to a kind of an upfold, compression will also lead to a downfold in order to gain equilibrium. So that is why you will observe that whenever that compression would happen, it would lead to the upfold. And as per Edward Seuss, when the formation of the Himalayas would happen, you had the hard rocks of the Peninsula Plateau to the south, and beyond that, you had a geosyncline which was created. Okay, the depression syncline formed due to compression. And upfold for the north. That is where syncline formation has taken place. Now, this syncline formation eventually, why it could not extend all the way to the various parts of the country? If you observe the physical map of the country, let me show you the physical map. So, something that we don't realize quite often. So, let's suppose, yes, this is the region of the northern plains here, extending all the way into the region of Brahmaputra plains also. This part about Bay of Bengal or the region of West Bengal and Bangladesh, will come to it later when we talk about the formation of Peninsula Plateau. But why is it that in this area the plains extend only to this extent? Why can't even the rivers, they start narrowing in this area? The rivers here, they are spread over all the wider area. Here, all the rivers, they accommodate themselves into this narrow area. Why does that happen? Because to the south, the Indian plate had the very dense, and rather not always very dense, but very hard structure in the form of Peninsula Plateau. So that Peninsula Plateau could not be folded in a simplistic manner. So that is why the region to the north was the one which got folded. Here you had the hard rocks of Peninsula Plateau. Rocks of Peninsula Plateau. Now these eventual syncline which got created across the wide area, you had rivers Indus, Ganga, Brahmaputra, all of them would be draining into that larger syncline which would be created. And they would be depositing sediments into them. And that is where eventually the sedimentary deposits which happened, that has formed the vast fertile plain area. So this is where sedimentary deposits by vast or Indo-Gangetic rivers. What together they are also referred to in geographical terms as Indo-Brahm rivers Together, they are also known as Indo-Brahm rivers. Here you can consider the Indo-Gangetic rivers, where you will find all these deposits. Okay, so all these deposits, they get created. So that is basically the case of northern plains. Why the compression is downward? So basically, take a piece of paper. When you try to compress it, there will be upfold and there will be another associated downfold also. Rarely will you come across a situation where only upfolding is happening. There will be a respective downfold happening somewhere or the other in order to gain equilibrium. As long as there is a scope to gain equilibrium, they will try to gain equilibrium. So that is why the compression will not only yield an upward fold, it will yield a downward fold. Now this deeper syncline which is created is in front of the Himalayas. Hence the term fore means in front or ahead, and then deep, that is the syncline. So this refers to syncline ahead of Himalayas. Ahead of Himalayas. Okay, that is the case of the formation of the northern plains. Right now, as you can imagine, that when the rivers would have come down the slope, they would have brought about various different types of sediments, rocks, boulders, everything would be brought down by these rivers, right? So the deposit would obviously not be uniform. In either circumstances, the deposits would never be uniform. So when the deposits would not be uniform, why and how? So the northern plains also have a variety in structure. Closer to the mountains, you will find larger rocks, larger boulders to be present, to be deposited, what is also referred to as the Bhabur tract. Then to the south of it, you have the Tarais, that is the very marshy land which comes into existence, super saturated with water, very rich in biodiversity. And then comes the alluvial plains that we have read about. So here, northern plains are formed by the alluvial deposits brought by the rivers, the Indus, the Ganga, and the Brahmaputra. It extends approximately 3,200 kilometers from east to west with an average width of 150 to 300 kilometers with an average width. The maximum depth of alluvial deposits, they vary between 1,000 to 2,000 meters. Now here, the entirety of the structure of northern plains, that is not going to be uniform, that is going to be distinct based upon what kind of deposits have happened. So you will observe immediately to the south or to the foothills of the Himalayas, you have something else. Then you have Tarai, then you have the floodplain. So how they are created. So let us try to understand that. So first of all, let us consider the mountainous region. Now, from these mountains, as the rivers would come, let's suppose, these rivers would have very high amount of speed, very high amount of speed. Kinetic energy would be very high. So these rivers immediately would bring large amount of rock pieces, rock paths, boulders, etc. down the slope, isn't it? Now, where would they get deposited? Now, these boulders, they would not be carried endlessly till the region of Bay of Bengal. They would be deposited somewhere immediately at the base of the slope where the rivers don't have that speed anymore. Their carrying capacity would reduce. So that is where these large boulders would get deposited. Okay. That is where you would observe these large boulders to get deposited. Now, once these boulders would get deposited, one on top of each other, from the top view, let's suppose you are having a top view from here. Will you be able to see the river? No, because on top of this, the boulders would have been deposited there. So it is oftentimes said that the river has disappeared, but it has not. The river is flowing where it is. It is just that large boulders and rock pieces have been deposited on top of it. And if ever you get an opportunity to go for camping in this area, adventure trail in this area, there you will always hear that horrifying noise of the river during the nights, which can be pleasant as well. But in the mountains, oftentimes that noise is so very loud that it basically will give you some amount of substantial amount of horrors if you know what the river can do, how it can suddenly outflow the entire region. So there, the river is said to be disappearing beneath the rocks, but in fact it has deposited the rocks which has shielded their view. If ever you get an opportunity to go to the north of, let's suppose, Rishikesh, there you will come across this scenario, because that is the region where the river Ganga, for example, is finally coming down the mountains, and from Haridwar it enters the plain area. So in the region prior to Rishikesh, all the way till Haridwar, you will find many such instances, many such patterns of the river where the river is almost shrouded and covered with the rocks. From a far away distance, river Ganga might seem to be very narrow to you. But if you start going closer, you will hear that noise that the river makes, and you would sometimes also realize that the rocks that you are standing upon, they are just supported by the other rocks, and underneath that, it is the river with its full gust and the full speed which is flowing. So think about it. Can agriculture be available or carried out? Can agriculture be carried out in this area, in this region of these deposits? Obviously not. So this is a region which is absolutely unfit for agriculture. Here or there, isolated trees you might find. One or two trees here and there, or a group of trees. Maybe a lot of rocks have been deposited in an area for millions of years, and there they have disintegrated to form that soil. So you might find isolated availability of trees here and there. But in the larger scheme of things, you will not be able to find any sustainable or any significant agricultural practice. Now, beyond the region of, this is what is referred to as the Bhabar Tract. The Bhabar region. Now, after this, the river has entered into the plains now. So its speed will obviously be less, very less. In comparison to the mountains, the speed will be less. If you still stand there, you will find the river to be swift only. In comparison to the mountainous area, the speed would have reduced. But now, when the river enters the plains, it enters for a brief moment in those areas where it doesn't have any predefined channel to flow. River channel, I hope we are aware that river channel, the cross section of it is where the river water flows. That is what is known as a river channel. Now, here, as the river basically emerges from the Bhabar tract, it moves into an area where it doesn't have a distinct pathway to flow. So, what will the river do? Imagine that it has brought in huge amount of water and no certain pathway in which it has to flow. What happens? In the floor of your house, if you, obviously in the floor of the house, you don't have such passageways for drainage, right? So let's suppose in the center of the floor, you pour in excess amount of one bucket of water. What will happen to that water? It will move and spread anywhere and everywhere. So beyond the region of Bhabar, The river experiences something like this. It moves, divides into multiple such branches. Multiple such branches, they re-emerge. And all these branches, they will move across a wider area. Again, Uttarakhand is one of the best places to visit and observe this kind of a movement or behavior of the river flow. So in the region of Rajaji and the Corbett National Parks, there you will find multiple such small rivulets. All of them might eventually, after a few kilometers, enter into river Ganga. But in that duration, in that interval, multiple such rivulets, they do get created. So here, this is the region where the river will have multiple small such divergences, multiple small such channels, which will drain through the entirety of the region. And that is where we refer to it as the Tarai belt, where the land will be very marshy, the soil will be supersaturated with water. This is what is referred to as the Tarai belt. By this time, in comparison, the river speed would have significantly slowed down. In comparison, not in comparison to the region of West Bengal, for example. In comparison to the region, let's suppose at the base of the mountains. At the base of the mountains, the speed would have been very high. The speed reduced. That is when the Bhabar deposits got created. Then it diverges into multiple smaller channels. The speed would have further been reduced. Then it finally enters the plain area, absolute flattish plain. Till now, till the region of Tarai, the ground would have had certain amount of slope directing the water somewhere. Now it enters the complete plain area. Now, in this plain area, the river will flow through a dedicated channel of flow, the fixed pathway that it has got. Now the river will move through the pathway. This is where they will start depositing the sediments to the sides. As the river will move, they will start depositing sediments to the sides. And these deposits to the sides, that is what we refer to as what? The alluvial plains. These deposits that occur to the sides, these are what are known as alluvial plains. Okay. Now, even in the case of these alluvial plains, the deposits are divided into or classified into newer deposits and older deposits. Okay. So even for these alluvial plains that you consider, they are classified into newer deposits and older deposits. So when you talk about alluvial plains, let's consider the cross section of the river channel. So let's suppose This is the region of a floodplain. Now here, if the river is moving, now let's suppose the river is moving through this channel. Now as the river is moving, let's suppose 100 years back, 200 years back, 50 years back, let's suppose, there would have been a very widespread flood. And that widespread flood would have inundated or flooded the entire region on this image. So the deposits that would have been carried by those floods, the older floods, the deposits would have been created here. In this entirety of the region, older deposits would have happened, isn't it? Here, older deposits would have happened when the river would have flooded it maybe 100 years back or 200 years, because every year the floods, they don't occur of the same intensity. You have certain cases that, okay, the floods which occurred in 1920s was so widespread that this much area was submerged. The floods nowadays, they are not so widespread, or maybe the floods which were observed in this region, in this particular area, was one of the most strongest or the most powerful in the past 100 years, etc. You come across these instances. So when you have had this kind of an older flood which would have created these deposits, so these deposits would have been created much earlier, never to be replenished again. They are not recharged frequently. It is not that every day or every week there is fresh things which are deposited here. Deposit has happened 100 years back, 150 years back, and it is never getting replenished. So what happens in these cases is that these deposits, the particles, they start combining with each other. Why? Understand, when the particles, they are present on deposited on top of each other, let's suppose, when the particles, they are deposited on top of each other, they will impose a weight on the bottom layers. They will always impose a weight on the bottom layers. As they impose a weight on the bottom layers, basically whatever calcium, etc., that these grains would have, that gets squeezed out, and that calcium joins the other particles, sticks the other particles with it. So as a consequence of that, you will have the presence of few of the larger particles now. So the soil's grain size will be larger in general. So this is the characteristic of the older deposits. Older deposits, which is also what is known as bhangar. Not very fertile. It is not very fertile, has got larger particle size. Not all the crops can be grown here. Crops like millets, maize, pulses can be grown. Oil seeds also, groundnuts. These are the types of crops which can be grown in these older alluvial soil. Where and when these older alluvial soils have been deposited? Long time back, when maybe there would have been an ancient flooding of the region. Long time back, there might have been such kind of deposit. Now, as the river is moving, it would basically, on a day-to-day basis, would also end up depositing large amounts of sediments on the sites. This would be replenished on a daily, monthly, and a weekly basis. So large amount of these fertile sediments would be deposited on the sides of the river channel. This is what is the newer deposit. This is what is the newer deposit, which is very fertile, which is brought by the river very frequently. Almost every day as the river is moving, we have seen for the formation of the floodplains that in the mature stage and the old stage of the river movement, the river will deposit sediments on the sides of the river channel, the formation of the floodplains. So that is where you have these newer deposits, and these newer deposits are very fertile, fine grained, and eventually you will observe suitable for almost all types of crops. They are basically suitable for almost all different types of crops. You will find that these newer deposits are suitable for. So these newer deposits, they are known by the name khadar. They are known by the name khadar. So again, I will repeat. When we talk about the alluvial plains will have newer deposits of sediments and older deposits of sediments. Older deposit of sediments which have been created by the river long time back. Newer deposit of the sediments which have been created recently and regularly. The older deposit of sediment obviously will be created far away from the river channel or the path of the river movement, very significantly far away from the path of the river movement or the channel of the river movement. That is where you will find the older uh, deposits to be in existence. Okay. Now, these older deposits, they are known by the name Bhangar. They are not very fertile. Meanwhile, the newer deposits which happen right across the river channel, right on the sides of the river channel, they are very, very fertile. That is why always for cultivation, you will observe that the favored land is always across the immediate floodplains, immediate vicinity of the floodplains. Floodplains can extend for a long distance, but the immediate region next to the river, that is where the fertility is the most. So that is your khadar. So here, when we talk about the Bhabar tract, so Bhabar is a narrow belt of 8 to 10 kilometers parallel to the Shivalik foothills. The river disappear in this zone as the rivers will deposit very heavy materials of rocks and boulders on top of them. Okay, they deposit heavy materials of rocks and boulders on top of them, and the area is not very suitable for cultivation or agriculture because obviously rocks and boulders, they will dominate. Now beyond the region of Bhabar, you basically have the area of the marshy tract. So it is to the south of Bhabar, which is known as the Tarai belt. Now here the streams and rivers re-emerge. Why the name word re-emerge has been used? Because for a long period of time, these rivers, they disappear underneath these rocks and boulders. So after that Bhabar tract, it appears as if the river has re-emerged. So here they re-emerge without any properly demarcated channel. Properly demarcated channel here refers to river channel, basically refers to when you observe a river, the path that they flow in, that is a river channel. It has got a kind of a depth associated where the water is carried. That is the river channel. So they basically emerge out of that flow, out of that region of the Bhabar tract, in a place where you don't still have a properly demarcated river channel. You still have the slope available, slight amount of slope available to the land. So as a result, the river will start moving in almost all different directions. It will start coming down to the slope. But in that region, it will create marshy and swampy condition, which is going to be very luxuriously rich in terms of natural vegetation and even wildlife. Very significantly rich in wildlife because vegetation will be ample. Why? Because first of all, in this Tarai belt, you will find the fertile soil brought by the river. Secondly, the river's movement will provide enough moisture because the river is moving into that wider area, diversifying into that wider area. So the entire region will tend to remain fertile. Now, that is why the region of Tarai belt or the Tarai tract, that is considered to be significantly fertile. Now, here you will find very dense vegetation. So, for example, you have your Corbett Tiger Reserve. It is situated in the Tarai Belt. The Pilibhit Tiger Reserve, also partly situated in the Tarai Belt. The Katarnia Ghat Wildlife Sanctuary, also situated in the Tarai Belt. Valmiki, for to some extent, also experiences that Tarai region. Then, even in the case of Buxa in West Bengal, also situated in the same region. So, in the entirety of the foothills, you will find these Tarai belts to be prominent in certain areas where you will have such significant flow and marshy swampy conditions, very rich in biodiversity, in wildlife. So, one horned rhino, elephants, then you have tigers, all of them to be significantly found. The entire region of Tarai was systematically deforested by the Britishers. It used to be one of the most densely forested area in the region of India, but it was completely deforested for various reasons. The deforestation which happened in the east around the region of Bengal and Assam, that deforestation primarily was carried out in order to bring that area under cultivation for tea, to supply the Western markets with tea. So that is where that deforestation happened, due to which one-horned rhinos were hunted almost out of existence. Then, in the region of the central portion, the deforestation which was carried out was primarily for the supply of wood, because in the late 1800s, you had a significant surge in the requirement of wood across the country of India. So, one of the requirements was for the manufacturing of paper and pulp. That is when the printing presses, they virtually exploded. Large number of readers would read the various different newspapers, magazines, etc. So printing presses, they started operating in significant, so they required paper. And secondly, for the manufacturing of railway sleepers, that is, you had the wooden piles or the kind of wooden slabs which were placed in between the railway tracks. So, for those railway sleepers, as the country would observe the expansion of the railway line, you had the deforestation which was carried out. It was during that point of time, in the era around the 1800s, when one-horned rhinos, they basically were almost hunted out of existence, even in the region of northern UP and foothills of Himalayas in Nepal. Otherwise, that was a region where you had a substantial population of one-horned rhinos to be originally living in that area. Okay, so that is your Tarai belt. Now, after that comes the alluvial plains. So when we talk about the alluvial plains, these are created in the mature and the old stage of the river movement. Now these alluvial plains, they are divided into Khadar and the Bhangar. So they get divided into Khadar and Bhangar. Okay, Khadar is the newer deposit. Bhangar is the older alluvium. So basically forming terraces higher than the floodplains. Deposits might have been created by very old floods and are not replenished regularly or after that. Whereas the newer alluvium, that is known as khadar. This is your newer alluvium. Fine grained and fertile. And fertile. That is the case of the newer alluvium. Okay. So the basically there you will find that in the older alluvium, they form a kind of a terrace across the region of the river plain. So what it indicates is that the older alluvium forms terraces across the region of the river plains. So this kind of a structure of the river channel might have been observed, where older alluvium deposited much earlier. There you will find larger calcareous structures, what is also referred to in the colloquial language as kunkars. So oftentimes you would have seen that basically when in your household, if the grains are sieved and sorted, you will find small, larger particles, kunkars, that are also sieved out and sorted out of the grain so that it is not ingested with food. So those are your kunkars. Okay, part of older alluvium. Now we move to the portion of the Indian desert. So when we talk about the Indian desert, that is the Thar desert, it is also what is known as the Thar desert. You have to understand few things here. First of all, this was a region which was not always a desert. The formation of desert in the region of Thar is a very recent phenomena. Okay, the desert formation is a very recent phenomena here. This was not always a region of the deserts. In fact, as the Indian plate was moving northwards, this would be the region which would experience onshore winds for a considerable period. When you had the Indian plate finally colliding with the Tethyan sea floor, and the subduction of the Tethyan sea floor was happening, the Tethys Sea was closing up, and the Indo-Eurasian plate collision was happening. As the Tethys Sea was closing up, it is estimated that at that point of time, some water of that Tethys Sea would also have seeped in or come into this area of Thar Desert and would have submerged many regions for a considerable amount of time. There would have been significant submergence of this region for a considerable duration of time. It is this submergence under Tethys Sea which makes this area rich in fossil fuel, limestone deposits, marble deposits, etc. But also, mind you, this is a region which has, among on the eastern extremity of it, it has got one of the oldest fold mountains of the world in the form of Aravalis. The Aravalis, which at one point of time would extend all the way till the region of Haridwar. Now that extension has been broken. Now it roughly extends up till the region of Delhi. And from the region of Delhi, you have very minor kind of uprised feature, which is also the Delhi Haridwar Ridge, what is known as. But these Aravlis were mighty mountains. So much so that it is estimated that there would be multiple glaciers originating from these Aravlis, because we find the evidences of the glacial landforms in the region. Multiple rivers would originate, creating fertile sedimentary deposits. In fact, even today, from the region of Aravallis, you have the river systems which originate, which create some amount of deposits of sedimentary soil in this area, what is also known as the Rajasthan Bagar. Okay. But the reason the Thar is a desert is primarily because of the alignment of the Aravallis. Why? Because when we talk about the branches of monsoon which can cause rainfall, the Arabian Sea branch of monsoon, which moves almost parallel to the region of the Aravallis in that direction. So orographic rainfall cannot happen there. The Bay of Bengal branch of monsoon, which comes from east to west, for them, the region of western Rajasthan lies in the rain shadow area of the Aravallis. Had the Aravallis got an alignment or a feature like this, let's suppose, then the region would have received tremendous amount of rainfall, availability of rainfall, isn't it? So that is where you will basically find that the reason for the region of Thar being a desert is largely attributed to the alignment of the Aravallis, but it was not always a desert. That is why even last year or the year before that, you had a team which found evidences of dinosaurs, the forest living dinosaurs. The fossils were found in this area of the Thar Desert. In the region of Bikaner area of Rajasthan, you find fossil fuel deposits along with crude oil and natural gas. That can only happen if the region has remained underwater. Okay. Limestone and marble is found. Marble is the metamorphosed state of limestone. How is limestone created? Limestone is created by the sedimentation of the marine shell-bearing animals. So that is why it has not always been a desert. Desert formation is very recent to the geological history of the region of Thar. It is very, very old, amongst the oldest areas of the country. So the Thar is a desert primarily due to the alignment of the Aravallis. Why? First of all, Arabian Sea branch of monsoon moves parallel to the Aravallis and hence no rains. Because you need the winds to hit the mountain so that orographic rains can occur. Please understand that along this entire vicinity of the Aravallis, at least on the mountain, on the hilly areas, you will have some seasonal rainfall, some amount of rainfall, due to which the Aravallis are able to maintain a green cover. It is a different matter altogether that due to illegal mining, which is rampant in the region of Rajasthan, in some portions of Haryana also, the illegal mining of and the quarrying, etc., which is very rampant, the entire Aravali hills are getting destroyed in front of our very own eyes. That is the only green patch which separates the Thar Desert from the rest of the plain area. So people are basically carrying out the illegal mining. They are scooping out large amounts of these hills and the mountains for their use. As a result of that, not only is the green patch getting removed, now when the dust storms from the west they come carrying huge amount of sand, then there is no barrier to stop those dust storms. They will inundate the region of Delhi and even the plain areas. That is why, in the recent past, those of you living in the region of Madhya Pradesh and Delhi, you would basically identify with the fact that nowadays you have a lot of these dust storms frequenting the areas, which was earlier not the case. That is because of the destruction of the Aravalis. Then, after that, for the Bay of Bengal branch of monsoon, Bay of Bengal branch of monsoon, the Thar region lies on the leeward side of the Aravalis. Or in the rain shadow area of the Aravalis, that is where they don't experience rainfall. That is why the region of western Rajasthan is a desert. Thar also extends into the region of Pakistan also. In the eastern part of Pakistan also, there is the presence of this Thar desert. Okay. Now, the Indian desert lies to the northwest of the Aravalli Hills. It is a land of undulating topography dotted with longitudinal dunes and barchans, right? The desert landforms that we have already talked. Low rainfall of close to around 15 centimeter per year. It has an arid climate known for low vegetation cover. In the local language, this is also a region which is known as Marusthali or the dead zone. Desert land features present here are mushroom rock, shifting dunes, and oases. Oases basically are the small water pools that you find in the desert areas. Mostly, you'll find that vast expanse of desert in between them. So, sand and sand everywhere, and in between them, suddenly you will find that pool of water. So, here there will be some moisture. So, maybe some trees also might grow here. So that is a typical desert oasis. So oases are the areas where the erosion has and the shallow presence of groundwater has brought water to the surface, where the topsoil has been eroded and the bottom layers there, the groundwater has seeped up. So that is what is known as an oasis. Okay. Aravali is a fold mountain. Yes, the oldest fold mountain in the country is the Aravali. Is it true that during Harappan civilization, Thar was not a desert as people with more density lived there than anywhere else? Yes, it is not correct, first of all. See, in the region of Rajasthan, you have some settlements, and it is also true that over a period of time, the western portion of Rajasthan has dried out much more due to deforestation. Desertification has happened. The expansion of Thar Desert has happened. Earlier, Thar Desert was not so widespread. That expansion has happened. But also, you have to understand that even the Harappan settlements, that the evidences that you find across some of the old river channels. Many of those rivers have dried out, maybe because of anthropogenic reasons, maybe because of climate change. Many of those rivers have now completely vanished and dried out. So it was across those river channels where you would find the evidences of civilization. Still, considered with all the other deserts, Thar is still the one of the most populated deserts across the world. Almost similar, Sakshi. Playas are more saline. Uh, Oasis is not always that saline. Ankush, Aravalis are continuously eroding naturally. In the absence of Aravalis, will desert be vanished? No, the deserts will expand. In the absence of Aravalis, the deserts will expand. What will bring rains to the region of Rajasthan then? There should be something which should bring rains to the region of Rajasthan. Then eastern Rajasthan will also stop receiving rains once the Aravalis go. And that is when the entire region will be very, very dry. So, to prevent desertification, conservation of Aravalis is a must. That is why the entire focus in environment ecology, you would observe, the entire focus of the various global programs is to prevent or save these Aravallis. It is not getting eroded due to natural process. Obviously, weathering has reduced the height significantly, but in our lifetimes, we won't be able to observe that natural erosion or weathering taking away that Aravallis. But in our lifetimes, what we have observed, at least in my lifetime, I have seen, only up till now, I have managed to see in the past decade. In the region of Rajasthan, there were hill tracks which have now basically have reduced significantly in height. So all the climatological influences that they had, that has disappeared. Okay. Mount Abu is facing 0 degrees Celsius temperature. So is Churu in Rajasthan. In Rajasthan, many places will see by desert. Please don't think that it will always be very high temperature. Winters are very cold in deserts. Even nighttime temperature is very low in the region of desert. Why? Because the air is dry. So the lapse rate will be very, very high. So even the loss of heat will be very quick. So that is why winters are very atrocious in the desert areas. Okay. Laghima, are you from Rajasthan? No, but I have. No, I'm not from Rajasthan. Have lived there, visited that region multiple times, but I'm not from Rajasthan. Okay. Now we come to the second portion of the physiographic divisions, where we start with the Peninsula Plateau. Now here, before initiating the discussion of the Peninsula Plateau, what is a plateau? A plateau is a flat tableland-like structure which gets created. Mostly because of volcanic processes. That is what and how a plateau gets created. Okay? A flat tableland-like structure. Now, when we talk about the Peninsula Plateau, it is by far the oldest landform across India, and there are certain estimates and studies which do claim that this might be the oldest amongst the oldest landforms across the world. But how have they been created? Were they created all at once? The answer is no. So when you think about the country India, the shape, the geological shape, do you think the entire country was created in this shape at one time, in one go? Do you think the entire Eurasian landmass would have been created at one go? No. When the formation of land was happening, you had small land bits which were getting created. Multiple of these smaller land portions, they would come together eventually to form a larger land mass. All of them would come together eventually to form a subcontinent, then a continent, and like that. So initially, you had small building blocks which would get created. Those were referred to as cratons. Small building blocks of continents. Now, many of the portions of the Peninsula Plateau, they have been created around more than 2 billion years ago. More than 2 billion years ago. So obviously, many of them obviously being created due to almost the entirety of Peninsula Plateau being created due to volcanic action. More than 2 billion years ago when you had this formation. So you can imagine that over the period of 2 billion years, the top portion would have been completely removed, completely eroded, completely weathered. It is the bottom portion which is now getting exposed. In fact, in certain areas, like the region of Ranchi in Jharkhand, you will observe that the top portion has not only been removed and eroded, it is the intrusive landforms which have now appeared to the top, the batholiths. The Ranchi batholith is a very famous formation. So those were at one point of time underneath the surface. They have now emerged. So when the top layers of these volcanic rocks are removed, the bottom layers are now exposed. That is going to be very rich in mineral deposits. The bottom portion of these volcanic deposits, they are rich in minerals. That is the reason why in the region of Peninsular Plateau, in various different areas, wherever there have been older deposits, lot of minerals are to be found. This is the reason why majority of the minerals across the country are to be found in the region of the Peninsular Plateau. But here, again, did the entire Peninsular Plateau come up in one go? The answer is no. You had individual cratons which came into existence. So first of all, just to give you an idea about it, you basically had initially the formation of the Chota Nagpur. I hope this color is visible. The Chota Nagpur craton, which got created. Then the Bastar craton, created almost simultaneously in a separate region, not in the same area, in a separate region. These individual land masses were created. It is said to be created the earliest. This is your Chota Nagpur craton. This is your Bastar craton. Eventually, what would happen is that these land masses would come together and collide. And you had so much amount of volcanic eruption that you will still find many of the older volcanic peaks in this area. In between the Chota Nagpur plateau and the Bastar plateau of today, you will find the presence of Garjat hills in Odisha. It is said to be a remnant of an ancient fold in between these areas. It was during this time itself, more than 2 billion years ago, when you had a series of such volcanic hills and mountains which were being built across the country due to volcanic activities, obviously. And that is where, here, across the eastern coastline, you will find those older hills and mountains. So these older hills and mountains created so long time back, what would have happened to their height after 2 billion years? Would their height have increased, or would their height would be completely diminished in stature? Obviously, weathering and erosion, the height would be diminished. One of the reasons why across the eastern coastline you will not find a tall mountain or a hill, because they have been created so long time back. But other land masses were also getting created. And when I say creation of land mass, I'm talking about volcanic activity bringing a land above water, island formation. And these islands would start getting together. For example, in the Chota Nagpur region, you have the Singhbhum area in Jharkhand, around Hazaribagh. Singhbhum region, you would have read in the Munda Ulgulan or the Munda revolt in the portion of history. So that Singhbhum region, very rich in mineral deposit. That Singhbhum area has got evidences of very ancient sandy beaches. How is it possible? The region of Jharkhand is never suspected to have been closer to the coastline or on the coastline. So how is it possible? So these were immediately small individual islands which were getting created. But you simultaneously had other land masses also. One of the land mass getting created was the land here and the folding of land in this region, creating the mighty mountains of those times. in the form of Aravalis, very mighty mountains. They would eventually, these were the fold mountains. At that point of time, it is said that it would have been formed as a result of a small continental landmass colliding with the nearby oceanic plate. So you can think about it. It was a fold mountain. Another landmass created at that point of time, very old, was the Bundelkhand Craton. The region of Bundelkhand that you find in the Gwalior Guna district. The Bundelkhand Craton. And in fact, you also had the creation of landmass in the southern part. Here, large plateau was created and formed in this area. That is the Karnataka plateau. This is what was the Karnataka plateau. Deccan traps were formed very recently in the geological history. It was formed around 90 million years back. These we are talking about billions of years back. Right? Now imagine such land masses getting created billions of years ago. Obviously, billions of years. For a brief moment, just try to digest that. The earliest form of human existence and human life that we are able to observe is basically only around few thousand years, 70, 80,000 years. Right? The evidences of dinosaurs, their extinction happened 65 million years. Their speciation is said to have happened around 300 million years back, 275 million years back. We are talking about 2 billion years. Planet has gone through multiple phases in that point of time. So imagine that these land masses would have been created. Multiple volcanic actions would be taking place. And at that point of time, just to give you an idea, this Chota Nagpur plateau is said to have been extended across this Meghalayan region as well. This would be the extension of the Chota Nagpur plateau. Okay, the Shillong Karbi Anglong region would be the extension of the Chota Nagpur plateau billions of years ago. Now, multiple streams would have originated. Many of the streams long time would have disappeared long time back. Maybe hundreds of millions of years ago, these streams would have disappeared from this area. But multiple such streams would originate. And they would create deposits, deposition of sediments, deposition of various type of materials, multiple types of vegetation, all of them, they would have been deposited, creating a kind of a contiguous landmass of this shape and size. Okay, creating a kind of a continuous landmass of this shape and size. Then basically, in the recent past, that is when the Indian plate finally started moving northwards from the region of Gondwana land. By that point of time, all these regions were well established. When the Indian plate started moving northwards from Gondwana land to the present position, for a brief moment, the Indian plate came over, for a brief moment of few million years, the Indian plate came over the Reunion Island hotspot. In its northward movement, Indian plate came over the Reunion Island hotspot. Now, that Reunion Island hotspot is a region which lies above the mantle plume. That Reunion Island hotspot is where you have a substantial amount of magmatic and lava eruption which continues to happen. It is suspected that across the planet, around 95 to 90 million years back, you had a spate of volcanic activity which rocked the entirety of the planet, which upended the entirety of the planet almost. Right? So it is suspected that at that point of time, India and the Indian plate was above the Reunion Islands. Now, from the Reunion Island hotspot, you had the supply of basaltic lava. Basaltic lava erupted. And it did not erupt at the same time. Obviously, the eruption was basically spanning over multiple thousand years, million years, etc. But the Indian plate, understand, is moving at a very slow speed, speed of around 15 centimeter per year at that point of time. Much faster than compared to today, but still 15 centimeter per year is still a kind of a speed which will keep you over a region for a substantial amount of time. So here, what happened was that this lava got deposited. In which area? In this region. In this region, the lava got deposited. Now, it is basaltic lava. Basaltic lava flows very easily. So it would flow almost like water flooding the region. Again, another eruption would have the deposit on top of them. In between those eruptions, maybe small streams, water systems would have come into existence. All of them would be trapped when the next eruption would happen, and again that basaltic lava would be spread. Like that, series of such eruptions and lava flow of the basaltic lava created multitude of these layered structures. Multiple of these layered structures would be created. From the side angle, if you observe here, this appears to be a kind of a step-like feature, isn't it? That appears to be a kind of a step-like feature that increased the weight. By the way, all this basaltic lava in certain areas, the deposits were many kilometers thick. Today we cannot even imagine kilometer thick lava deposits. There were multiple kilometers thick lava deposits which would have happened. So on the sides, they represented a step-like feature. This step-like feature would be referred to as trepan, and from here, the term traps was basically derived. And this is why this entire area, this region, this is also what is known as Deccan traps. This entirety of the region is also what is known as the Deccan traps. Okay, so that is what you observe in this entirety of the region, right? Now, here, as this was happening, the height was slightly increasing across the western side of this plateau. But something else happened. There was a fresh wave of eruption which wanted to come out. But by this point of time in this area, you had kilometers thick of lava deposits. So imagine if you have this impenetrable, impermeable layer of lava deposit in this area, and you have fresh eruption which tries to come out. It won't be able to penetrate through the surface because the surface is solidified, hard, igneous rock. So when it won't be able to penetrate through the surface, what would it lead to? It would lead to a kind of an intrusive landform, but at the same time, they would alter the slope. So that is when the slope of the Peninsula Plateau developed a distinct west to east side. So western side would be higher, eastern side would be lower. That is the reason why even today, almost all the rivers of the Peninsula Plateau, even if they originate along the region of the Western Ghats, they will drain into the region of Bay of Bengal, because that is the slope of the land in this area. Now, all the older regions which have been eroded, these older regions, now it is the minerals which are closer to the surface which can be exploited. Right? So that is basically what you will find in this. That is why these areas are very rich in minerals. So even amongst the Peninsula Plateau, which will be the region rich in minerals, the older ones amongst them. So the Chota Nagpur region, the Karnataka Plateau region, the Bastar Plateau region, the Bundelkhand region, and the region of Aravalis. You will find more or less almost all type of minerals in this area. But then, as I had told you, that the Meghalaya Shillong Karbi Anglong Plateau was also an extension of the Peninsula Plateau. So what happened? How did it get separated? So basically, when the Indian plate was colliding with the Eurasian landmass, at that point of time, there was a huge impact which was created in the solid portions of the Indian plate. Huge impact. Various cracks and faults developed. At that point of time, even this western portion extended further into the sea. Here also, this was a part of the landmass at that point of time. But when the Indian plate did collide finally with the Eurasian plate, the impact was so heavy that it is said multiple fault lines they did develop. One of such fault lines developed in the region of the western coast, and one of the fault lines they developed here in this area. And then these areas, they simply subsided. They simply sank down because they got disjointed from the nearby land masses. So they simply started sinking down. And then that is where River Ganga, Brahmaputra, etc., they found an exit path to flow from this area. That is why immediately beyond the Rajmahal hills here, you'll find River Ganga takes a southward bend. And not only did they start flowing through this area, they deposited significant amount of sediments in that area. Large amount of sedimentary deposits were created, led to the formation of the fertile plains in the region of Bangladesh and the region of West Bengal. Had that fault line not been created, then the water of Ganga and Brahmaputra would have continued to accumulate in this area. So that is basically when the land went down. So this region, this gap, that is what is known as the Rajmahal Garo Gap or the Malda Gap. Or Malda Gap. Okay, that is what is the Raj Mahal Garo Gap, or what is known as the Malda Gap. In the western coast, what happened? In the western coastline, that entirety of the landmass where you had this crack which developed, that simply went underwater. And that is the present day's continental shelf. This is the reason why, despite having this, or even if you take the case of the shape of the western coastline or the Western Ghats in itself, Western Ghats are an escarpment. We have discussed them time and time again. Western Ghats are an escarpment. Why? Because earlier, the land was somewhat like this. Let's suppose there was a crack which developed and this portion simply went down. So that is what has become the continental shelf in this wide area. This is the reason why, despite having steeper slopes across the western coastline, the continental shelf across the west is very wide. Okay, because there has been a distinct continental shelf formation because of the subsidence of the landmass. So that is the entire process of the formation of the Indian subcontinent. Now, here we have talked about the mineral distribution also. Later on, by utilizing this same concept, we will be able to understand the soil distribution also as observed in these areas. Okay? So, why many minerals are not found in the region of Deccan Traps? Because created only the volcanic eruption has happened and the lava has been spread only around 90 million years back, whereas in the remaining areas the deposition has happened 2 billion years, 2.5 billion years ago. So that is where there is a wide variety. In the older areas of Chota Nagpur Plateau, Bastar Plateau, etc., the top portion has completely been eroded and been removed off. So the lower portions are the ones which are now exposed, which are mineral rich. Okay. And what is the oldest landmass all over the earth? There are still some of the rocks in Australia, they have an indication that they were formed 3 billion years ago. So we still don't know which is the oldest one. What happened to the fault on in the west? That is what I am saying. The fault in the west here, the portion of the Western Ghats escarpment was left, the remaining portion went underwater. Okay, Ankush, why not Deccan Traps for what? For mineral deposits? I think I have answered that. Is this why? This is why continental shelf in western coast is wider than the eastern side? Yes. That means we can say continental glaciers also existed in Chota Nagpur Plateau? Yes, they did. In many portions of the peninsular plateau. For example, in the Gondwana coal deposits, which are 200 million years old, underneath them, beneath them, you have evidences of glacial landforms, glacial deposits. So, on top of them, millions of years of deposits have happened. So, yes. Okay. Not clear with the region of the Malda Gap. So, the Peninsular Plateau would extend even in this area all the way to the region of Meghalaya, Karbi, Anglong, and the Shillong Plateau. Now, when that collision happened, there was development of a crack in the Rajmahal Hills here in the region of Malda district in the present day West Bengal and in this area also. And there was a development of a fault. Now, when a particular landmass gets isolated from all of its sides, what will happen? That landmass will simply sink. That landmass will simply subside. Right? It is in that area that the various rivers they started moving and they created a fertile sedimentary plain out of that. That is, so that there is a gap in the peninsular plateau between the region of the Chota Nagpur Plateau and now the older Meghalaya Plateau, which also was a part of the peninsular plateau. So that gap is known as the Rajmahal Garo Gap. Rajmahal Hills on one side, Garo Khasi Jaintia on the other side. So the Rajmahal Garo Gap, or it is also known as the Malda Gap. Okay. What is the reason of the fault? The collision between the Indian plate and the Eurasian plate. Fair enough? Yes, these are all normal faults. So now we take a break. We take a break for 15 minutes and we'll be back in 15 minutes and we will continue. A confirmation about the audio, please. If the audio is clear and working fine. Thank you. So, when we talk about this peninsular plateau and the extent of the peninsular plateau in general, so from the north, it basically from the region of the Aravalli ranges and the Aravalli Ridge, the Delhi Ridge, which is a part of the older Aravallis, that is considered to be the northernmost extent of the peninsular plateau. Okay, so the Delhi Ridge in the northwest is the northernmost extent. Then the Raj Mahal Hills in the east. Here is where you have the Raj Mahal Hills. That is the easternmost extent. Gir Ranges to the west, Cardamom Hills to the south, and the Shillong and Karbi Anglong Plateau, the Meghalayan Plateau, that is also an extension and a referred extension to the Peninsular Plateau system. So that is basically the extent of the entirety of the Peninsular Plateau system. Now, broadly, it is classified into three parts. You have the Deccan Plateau, which consists of the Karnataka Plateau, the Telangana Plateau, and the Deccan Traps. They are included in the region of the Deccan Plateau. Karnataka Plateau, Telangana Plateau, some parts of even the Bastar Plateau, that is also included in this. Bastar Plateau. Ideally, in the map, you should observe where they are. In the physical map of India, you will find these. You should ideally locate where they are. The Bastar Plateau, then the Deccan Traps, okay? This is where you will find the presence of the Deccan Plateau. The Central Highlands includes the region of Vindhyas and the Satpuras. Vindhyas and Satpura. In the southwestern extent of Madhya Pradesh, you will find the Malwa Plateau. Malwa Plateau. To the east, you will find Chota Nagpur Plateau also. Then the region of Bundelkhand and Baghelkhand. And Baghelkhand. That is also to be found in the same area. Okay. And then the northeastern plateau, that is the region of Garo, Khasi, Jayantia, and basically the Shillong, Karbi, Anglong, the entire plateau region. So that is the Shillong, Karbi, Anglong. And Karbi Anglong Plateau. So that is also to be found. So this is the various classification. Ideally, what you should do is on the blank piece of map, you should point out where they are. The physical map of the country, if you open up, you will find these plateaus interspersed, the name given, and the various physical features. So, for example, the Aravallis will be situated here. Vindhyas and Satpuras almost parallel here. Here you will have the Chota Nagpur Plateau in this area. You will find the presence of the Chota Nagpur Plateau. Here you will find the presence of the Bastar Plateau in this area. Here you will find Ramgarh Hills in this region, Kaimur Hills to be present in this area. Malwa Plateau is present here. Then the Bundelkhand region, Baghelkhand region, Telangana Plateau, Karnataka Plateau, and the region of Garo Khasi Jayantia, that is the Shillong Karbi Anglong Plateau. that is also considered. Okay. Why Garo Hills are not considered as the easternmost extension? Why should they be considered? First of all, in the mainland itself, that is where we consider the Rajmahal Hills to be the easternmost, because in the so-called mainland of the country, that is where you have, other than the northeastern division, this is the portion where you have a contiguous extension of the Peninsula Plateau. But in the Peninsula Plateau, you will also find that here you have the Shillong, Karbi, Anglong Plateau. So Garo, Khasi, and Jaintia. So if you have a doubt, it should be that why Jaintia is not considered, not why Garo is not considered to be the easternmost. So that Garo, Khasi, Jaintia region is considered to be an extension or the presence of the Shillong, Karbi, Anglong Plateau in itself, which is an extension of the Peninsula Plateau. Okay. Now, then we come to the eastern and the western Ghats. Now here, we do know that the western Ghats, they are an escarpment. They are an escarpment means that they have been created due to the formation of a fault where one portion of the landmass has gone underwater. So here, western Ghats is an escarpment. What are Ghats, by the way? What do we understand by Ghats? So in simplest of the terms, these ghats, they are generally referred to as the region of the slope of the plateaus. That is what the ghats are used to indicate, where from a particular height they take you to a certain lower elevation or vice versa also. So these western ghats and the eastern ghats, they depict the border of the Peninsula Plateau, denote the borders of eastern and western extent of Peninsula Plateau. Okay, the border of eastern and western extent of the Peninsula Plateau. Now here, we have seen about the formation of both of them. Along the eastern section of the plateau, that is around the region of the Bastar Plateau, the Telangana Plateau, the region of the Karnataka Highlands, etc. There, the formation of these landforms, hills, etc., they have been formed much earlier, long time back. So in the region of the Eastern Ghats have been formed a lot earlier. So when we talk about Eastern Ghats, formed a long time back. So basically billions of years old. So here, rivers and streams. So weathering and erosion has reduced the heights, the heights, and then basically rivers. We know that all the rivers, most of the rivers in the region of the Peninsula Plateau, because of that height, they height across the western part, they move from west to east. Majority of the rivers, they drain from west to east. So majority of the rivers drain from west to east. So here they have made the Peninsula Plateau or the Eastern Ghats in particular discontinuous. So here, if you observe this, observe these eastern ghats. They are not continuous features. They are broken in between. You have the Krishna Godavari rivers, they drain into that area. So they have eroded that region over a period of time. Now, if you observe the Western Ghats in comparison, now Western Ghats are an escarpment. Okay. So if the Western Ghats are an escarpment, so how is the escarpment formed? As a result of normal fault. One portion has gone underwater. So this escarpment formation has been a very recent phenomenon. And the rivers are not dissecting this Western Ghats as well. So that is why the Western Ghats, which are also known by different names in the regional areas, Sahyadris in the region of Maharashtra, Nilgiris in the region of Karnataka and Kerala. So that is where they are much more continuous and they have a steep wall-like feature. So when we talk about the formation of the Western Ghats, these are basically an escarpment. Created due to normal faults. Fault formation. That has been created due to a fault formation. Okay. Now here, basically, try to understand a larger concept here. We will discuss some concept about the coastal plains also here. So listen to this. So at one point of time, it is said that this region would have been somewhat like this before the formation of a fault. Now, and here, let's suppose there would have been water in these areas. Now, over the geological history of the planet in the recent past, the land has also emerged from above water across the eastern coastline in particular. The land has also emerged above water. We'll come to that. But when the collision with between the Indian plate and the Eurasian plate happened, a crack developed and this portion simply went underwater. So as a consequence of this, the landform which got created was somewhat like this. Okay, where you basically had water here, you had the water here, and at the bottom you had the older landmass which still is underneath the region of Arabian Sea. The reason for a wider continental shelf across the western coast. Now, when we talk about the coastlines and when we talk about development of ports and harbors, what is it that is required for a natural port or for a natural harbor to exist? What are the features that are required? You won't find everywhere there is a harbor which is being built. The water has to be deep enough near the coastline. Why? Because when the large ships come, a significant portion of that ship is underwater as well. So if the waters are not deep enough, the ship will never come close to the coastline. Never. That is why even today you will find that majority of the ships, they are basically anchored far away from the coastline from their small boats and ships. They bring the materials on shore because they can't come in the region where the water is very shallow, right? Because the ship will get stuck. So that is why these ships always require deeper waters. That is where the best harbors or the natural ports are the ones where the water is very deep across the coastline. Now, out of the eastern and the western coastline, Where is it that you find the water to be deeper closer to the coastline? Always across the western coastline. In the eastern coastline, you will find that the water is not very deep due to the shape of the landmass. The water is not very deep. Here, the water is deep enough, which can accommodate these large ships. That is also the reason why western coastline is naturally suited to have multiple different harbors and ports. In eastern coastline, only Vishakhapatnam has got that ability or that natural feature where it is deep, very close to the coastline. Otherwise, the water is shallow. That is why Chennai port, every few months, it has to go undergo maintenance for the deepening of the water in the near the coastline to remove that excess sediments, etc. The Kamrajar port, which is built immediately, Ennore port, which is built immediately to the north of Chennai port, a lot of money was spent to dig that underwater sand to create that depth. And I hope we are also aware that none of the ports in India are deep enough to handle the largest ships of the world, what is referred to as the Panamax class. So none of the ports in India are deep enough to handle the largest ships, container ships. So what do these large container ships do? If they have to bring certain materials to India, they basically take it to Colombo port. From Colombo port, medium level vessels, they basically transport those materials and come to JNPT or any other Indian port. This is where, near the region of Tiruvananthapuram, you have the region of Virinium. You would have heard about the Virinium port so much in discussion for the past year due to huge amount of protests which were being carried out in the region of Virinium, because the government is building a port there. It is a deep water port where the water close to the coastline is as deep as 20 meters, which is significant, where large ships can easily be accommodated. Now, that Virinium port, if it comes into business, it has got the potential to put the Colombo port out of business. Because any day, there is larger bulk of goods which try to come to India as compared to Sri Lanka. Colombo port has got a depth of 15 meters close to the coastline. Most of our ports have a depth less than 10 meters. So that is where the Virinium port's development has got a huge potential in the coming decades for India, where the largest of the vessels can now come to India. And imagine, India can be that transshipment hub where these larger vessels, they offload their goods if we provide that infrastructure, obviously, and those goods then will be loaded to the smaller vessels and they can be transported, let's say, to the region of Sri Lanka, to other Southeast Asian nations, maybe some portions in the vicinity. So we will be able to save a lot of money and earn also by these vessels. That is where Virinium port and the development of it was something that, even for that matter, the state government was pushing through, but also the central government significantly. The construction of it has been delayed quite significantly because of the year-long protests which happened. Eventually, some sort of compromise was reached. And then, if the Virinium port remains free of these protests, which is the normal case with almost all the infrastructure projects in India, they run into some kind of obstruction or the other, due to which their construction gets delayed. For example, look at the bullet train project. Was supposed to be constructed and completed by the year 2020 and 2022. Now, the most optimistic estimates take it to the year 2028. So same is the case with the Virinium port. But that brings to the question that why western coast is more suitable to have these natural ports and harbors as compared to eastern coastline. Okay, So here, the continental shelf is wide enough, but it is basically, as you can observe, there is a difference. In the western part, the continental shelf is wide enough, but the land will represent a kind of a depth closer to the coastline. So this is a continental shelf, but at a certain depth. Whereas across the eastern coast, you have a plain-like land, and here the waters come in. So you can imagine that the largest ships will be many, many kilometers off the coastline. That is why construction activities are carried out to dig this deeper, to maintain that depth across the eastern coastline, other than Vishakhapatnam port, which naturally is a deeper water port in comparison. Okay, Ashish, I hope that is clear. And Shreyas, I hope that is also clear. Continental shelf does not see continental shelf. What is the depth that we have seen, the maximum depth that a continental shelf can have? Almost 200 meters below the sea level. 200 meters is quite significant. Here, you in the western coast, you don't have the depth of 200 meters. But even if you have a depth of more than 20, 30 meters close to the coastline, that is enough. But in the eastern coast, you don't have that. Even if you go to visit the eastern coastline and the western coastline, you'll find that difference. In the eastern coastline, the water is very shallow. You can walk further up into the water. In the various beaches across the eastern coastline, water is not that dangerous looking. But go across to the western coastline. Immediately, the water is very deep. Immediately. You walk 15 steps into the sea, you will find the water above your level of the head. So that is the characteristic associated with the coastline. Okay. Now, then we come to the characteristics. So Western Ghats demarcates the westernmost extent of the Peninsula Plateau. It forms an escarpment on its western slope, thereby being able to influence rainfall, because almost vertical wall-like section is created by these Western Ghats. It was formed due to the submergence of a part of land into the sea. They are known locally by different names: Sahyadris in Maharashtra, Nilgiri in Karnataka, Tamil Nadu, Anamalai and Cardamom, again in the contiguous region between Kerala and Tamil Nadu. Whereas when we talk about the Western Ghats, they are comparatively higher in elevation and more continuous as compared to the Eastern Ghats. Now here, ideally, UPSC has asked from this area multiple times, the previous 5 to 7 slides that we have discussed. One time UPSC had given a map, match the following kind of a question in prelims, that Baghelkhand is present in which of these states? Bundelkhand is present in which of these states? So that location from the map you have to pick up. Again, another question which UPSC had framed as recently as 2017, I think, was that the Western Ghats are present in how many states? So the Western Ghats, they are present in the region of Gujarat, Maharashtra, Goa, Karnataka, Tamil Nadu, parts of Kerala. So there are in total 6 states. So these factors you have to be consistently exploring with the help of the maps. Now, if you learn, it is not as if UPSC is going to repeat that question, but I hope you are able to understand the trend of questions that UPSC is going to ask. Okay, about these physical features and the political region where they are extending to. Now, the Eastern Ghats. So, the Eastern Ghats run from northern Odisha through Andhra Pradesh to Tamil Nadu in the south, passing through some parts of eastern Karnataka. They are eroded and cut through by the 4 major rivers of Peninsular Plateau, that is Mahanadi, Godavari, Krishna, and Kaveri. Some of the important ranges include Javadi, Palakonda, Nalamala, Mahendragiri Hills. These are some of the important hill ranges. They meet each other at the region of Nilgiri Hills in the south. Now we come to the coastal plains. Now, here again, when we talk about the coastal plains, think about it for a brief moment. Majority of the rivers, they drain from west to east. The rivers will carry out the deposit. So majority of the rivers, they will carry out deposit where? In the western portion or the eastern portion? Obviously in the eastern portion. That is why the eastern coastal plains, they are much broader as compared to the western coastal plains. Western coastal plains, they are very, very narrow. Right? If you take a look at even history, I am assuming all of you have studied history, ancient medieval history. In the portions of history, you would have come across a scenario where almost all the kingdoms, they would be vying for control of the region of eastern coast. Western coast also, but western coast, they would basically eye for control of western coast only in order to have the access to trade, because even historically western coastline was used for trade. The eastern coastline would be used for cultivation, agriculture. Take the case of the mighty Cholas, the Gangas, all of them. They would control the eastern coastline. And the huge amount of agricultural output that they would generate would earn them significant amount of revenue. Now, when we talk about the coastlines, western coastline is known as a submergent coast. Obviously, because a portion of land has gone underwater. Okay, so the western coastline is known as the submergent coast. The eastern coastline, that is known as the emergent coast. Why? Because historically it has happened that the region of the eastern coast, some portion of it has come above water millions of years ago. Another reason why the continental shelf across the eastern coast is very narrow, because there has been a slight adjustment which has happened like this. Now, these coastlines and coastal plains, they are known by different names in different areas. For example, when we talk about the eastern coastline, so here, the northern portion of the eastern coastline, that is known by the name of northern Sarkars. Northern Sarkars. The southern part of the eastern coastline, that is known as Coromandel Coast. Even further, if you analyze, just let's suppose the Odisha coastline. The Odisha coastline, that is also what is known as by the Utkal coast. Similarly, western coast is also given different names. When we talk about the different names of the western coast, here you have the Kutch and the Kathiawar coastline in the north. That is where the western coast is a bit wider. That is the region of the Kutch and the Kathiawar coastline. Then you have the Konkan coast, where the coastline is very narrow. The very famous route, picturesque route of the Konkan railways, always advisable to travel through the region of the Konkan railways whenever you get the opportunity. Engineering marvel to itself, and also you get to witness the natural variation where basically you will have the trains passing through the tunnels. On one side you will have the escarpment of the Western Ghats, on the other side you might be able to see the estuaries and the Arabian Sea itself. So very nice area. Then in the region of Karnataka, it is also known by the name of Kanara Coast. And then it gets broader again in the south. Flat low-lying area of deposit, that is the Malabar Coast. that is the Malabar coast. So that is basically the entire classification of both these coastlines. Western coast is referred to as the submergent coast because some of it has submerged underwater. Eastern coast is known as the emergent coast. Eastern coast is much broader, western coast is much narrower. Western coast, you will not observe the formation of deltas, only estuaries. Eastern coast, you will find the formation of both deltas as well as estuaries. What is the difference between a delta and an estuary? So when you observe a delta, in the case of a delta, the river will carry out its deposits before meeting the sea. If this is the sea, this is the river. So they will carry out the deposits. That is a delta, isn't it? When you talk about an estuary formation, here this is your delta. Estuary formation is where you will have the sea water come inland. This is the river. So the sea water comes inland, and this is the region where the sea water mixes with the river water. That is an estuary. So here, when we talk about, sir, cause eastern coasts are mostly Himalayan rivers. Which are the Himalayan rivers in the eastern coast other than the region of Ganga, Brahmaputra, which we don't consider in the portion of the eastern coastline? Which are the Himalayan rivers which drain into the eastern coastline, my dear friend? Please let me know. How can there be an upliftment of the eastern coast? The the upliftment subsidence of the landmass, that is a continuous process which happens due to the endogenic forces, in part of that epirogenic forces which can cause the upliftment. And what the theory basically postulates is that ever since there was that massive amount of volcanic outburst across the western part of the plateau, which increased the weight by the basaltic lava, so that led to a slight readjustment. That is one of the theories. Another theory which tells us is basically that after the last ice age, when you had the water level which reduced, at that point itself, you had, due to the imbalance, some amount of land which came up above water. So there are numerous theories prevailing around why the land came up. Okay. Now, western coast don't form coastline, doesn't. Narmada and Tapi. Megha, what is the example of where you are saying about Narmada and Tapi? Form, have deltas. Why? So, there are two reasons for that. First reason is basically majority of the rivers drain to the east. Very few move to the west. Amongst the larger or medium distance rivers which drain to the west, you have the case of Narmada and Tapi. But both these Narmada and Tapi, they drain through a rift valley. A rift valley system is what? When you consider a rift valley, so this is like a structure like this. Maybe river is flowing at the region of the rift valley. So here, the river has not got much of a scope to either go for the horizontal sideward erosion or the vertical downward erosion. River doesn't have much scope to erode. because it is already flowing through a depressed area in the channel provided and the pathway provided by the Rift Valley. So if you don't erode enough, how will you be able to deposit enough to form a delta? When you take a look at the major rivers of the eastern coastline, Mahanadi, Godavari, Krishna, Kaveri, all of them, they cover 1,000+ kilometers moving through this rocky terrain, eroding materials. That is why they are able to create and carve out large deltas. Okay, so here, Narmada and Tapi drain through rift valleys, hence not much erosion is observed. And other rivers of the western coast that you will observe, maybe a Bharatpuya or a Periyar, these rivers, they are very small. Even if you consider Zuari or Mandavi through the region of Goa, these are very small rivers. They don't have enough of the movement through the plains to create deltaic formation. That is why in the western coastline, you don't have significant or any much of the delta formation. So here, other rivers of the west are very small and drain do not carry enough materials to create delta. Okay. Don't worry, the SME will reply as soon as possible. I would urge the subject matter expert as well to reply to the questions as soon as possible. Now, that is the case of the coastal plains. Now, I hope we are aware that why western coastline will not have delta, right? This was a question which UPSC has asked once, in fact, a couple of times in the mains examination. So that is something that you should be able to tell. So when we talk about the western coast, you basically have various different ports across the western coastline: Kandla, Mazagaon, JLN Port, Navasheva, Marmagao, Mangalore, Cochin. These are some of the important natural ports. Now, the western coast will be divided into the Kutch and the Kathiawar coast, where it is broad, Konkan coast in the region of Maharashtra and Goa, where it is the narrowest. Then Malabar coast in the region of Karnataka and Kerala, where again this coastline gets broader. Now, the western coastal plains, they are narrow in the middle and they get broader towards the north and the south. No delta formation takes place. Malabar coastline in certain areas, here it has got a distinguishing feature of backwaters. What are the backwaters? So in certain regions where the level of the land is very low, you have a low-lying land area. For example, if you go to the region around Kovalam in Kerala, even around the region of Elepi, you will find a lot of these backwaters. So where the level of the land is very low, if let's suppose here you have sea, from certain low-lying areas, the sea water ventures inland. And in these areas, from where the sea has entered inland, that will form a larger saline or a brackish water body. Large, saline water body. These are your backwaters or canals. Many of the times what also happens is basically, let's suppose you have a region like this, and you will basically observe, let's suppose in that area, a river is flowing through. A river is coming into that area, let's suppose, and draining into the sea. Now, the region through which the river flows through is going to be a lowland, region. So sometimes the seawater enters through this lowland area. And that is when it will convert the larger area into a very saline, brackish water body. It will be converted into a very saline, brackish water body. So this will also be what is known as backwater. Excuse me. So that is how the backwaters are created. Here you have the very famous boat race which is conducted on the sides of these backwaters. You have very beautiful and picturesque mangrove vegetation. The very famous boat race which is conducted, what is the trophy known as? Are we aware? Let me know, find it out. Now, the eastern coastal plain, that is also what is known as the emergent coast and is significantly broader. So here, well-developed deltas are formed by the east-flowing rivers to the region of Bay of Bengal. Yes, the Nehru Trophy. So here, you'll find the presence of both deltas and estuaries. Presence of both deltas and estuaries. Both of them will be found. So deltas of Mahanadi, Godavari, Krishna, Kaveri, etc. that is observed. Then we come across to the island groups. India, we have already discussed on Saturday, that India has got two distinct island groups. Both of their role and importance, strategic importance and relevance is also something that we have discussed. We have an island group in the region of Arabian Sea in the form of Lakshadweep. And we also have an island group in the region of Bay of Bengal in the form of Andaman Nicobar Islands. Now, almost both of these islands, they have different form of origin. When we talk about the region of Lakshadweep, for example, Lakshadweep, how are they formed? Lakshadweep is an example of coral islands. Very good. These are your coral islands formed out of those coral reefs and the coral polyps. We have seen how the beaches get created and how these islands also get formed eventually. When we talk about Andaman and Nicobar, however, how are they created? We have discussed that also. Andaman and Nicobar. How is their creation? Very good, Sakshi. Ankush, correct. No, Gunjan, it is not a divergent plate. So, volcanic eruption, most of you are correct. But why that volcanic eruption has occurred there? Why in the region of Andaman Nicobar only that volcanic eruption has occurred? Very good. Mega, Anjan, perfect. Brajneet, correct. Bhima, it is basically the Indian plate and the minor Burmese plate. They have converged. So if I bring you back to this image, observe here, this zone of convergence, let me represent it by different color. This zone of convergence continues here. Here you have the fold mountains across this zone of convergence. And here, observe this. It is in a shape of an arc which continues all the way to the region of even the Indonesian islands. In the region of Indonesia also, you will observe that same arc. That is why Andaman Nicobar, in geological terminology, is also oftentimes referred to as the northernmost extent of the Indonesian arc. Okay, it is referred to as northernmost extent of the Indonesian arc. So here, the formation of Andaman Nicobar is because of convergence of oceanic crust of Indian plate with oceanic crust of minor Burmese plate. That is why to the west of Andaman, you will also find a very, not very deep, but a minor Andaman trench will also to be is also to be found in the region around Andaman Nicobar Islands. So because of this, you have formation of volcanic islands and seamounts, underwater mountains. These seamounts sometimes can create coral islands, coral reefs, which eventually can become coral islands. Okay, that eventually can end up becoming coral islands also. So that is the case of Andaman and Nicobar Islands. Now, the formation of Lakshadweep also we have seen, the formation of Andaman Nicobar. This is the reason why India's only active volcano is to be found in the region of Andaman Nicobar Islands. That is the barren island to the east of the Andaman group. That is where you will find them. Okay. Now I will give you one question as a homework. Try to create an answer out of that. You know all the details about this. Why does the region of Himalayas experience more landslides as compared to the Western Ghats? Okay, try to find out the reason for this. Try to create an answer. I don't think any of you should find any difficulty in answering this particular question. That bring about the climatological aspect also. Okay, bring about more cloudburst in the region of the Himalayas. The tectonic activities in Himalayas are very prominent. The slope is still increasing, frequent earthquakes, all these factors you can basically bring about. Ideally, you should try to write it within or try to create an answer in 250 words. Okay. Now, then we move to the portion of the drainage systems. In the portion of drainage systems for your prelims, drainage pattern, sequent and insequent streams, these are the ones which are important. When we come to rivers of India, in the immediate next module, there you will find portions relevant again both for prelims and mains. Here, in the case of the drainage systems, only this much portion is going to be relevant for your prelims portion. Mains questions you should not ideally expect. If UPSC goes out of its way to create an easy question, it might create a question that discuss about all the various drainage patterns that you can observe, etc., etc. Very easy fact-based questions. Now, here, when we talk about the drainage system, what do we refer to? So when a land comes into existence, whenever, any kind of landform, when it gets created, when it comes into existence, over a period of time, certain regions will start receiving rainfall in concentration. Streams will come into existence. Water will begin to flow. Now, where does the water flow? In which direction will the water actually indicate a movement? That will be always indicated by the slope of the land. Whether the slope of the land, in whichever direction it is pointing the water to, water will automatically go in that direction. Now then, the behavior of that stream or the river, that will be dependent on what? The rocks which have formed that land. Whether that land has been created by igneous rocks or sedimentary rocks, or maybe only sedimentary deposits, the pattern of the river flow will vary. For example, if I give you two conditions, one is A, where you have igneous rock formations, let's suppose, and another I give you is B, where you have sedimentary soil formation. The base is made up of sedimentary soil. Out of A and B, where it is A is igneous, let's suppose, B is sedimentary. Out of A and B, in which of this place is a river more likely to form a meander? A or B? What do you think? Where will river most likely develop a wavy pattern? Almost all of you are correct. Sedimentary region. Why? Because it is soil. It is made out of softer structure. So in the case where this softer structure is present, the river can basically erode in whichever way it wants. The river can flow in whichever way it wants. So that is where the nature of the rocks in a region, the slope of the land, how old the rock is, that in a way decides the pattern of the drainage system or the behavior of the drainage system in itself. So drainage system is always going to be an outcome of the topographical realities of the region. For example, in the Peninsular Plateau, the slope of the land is from west to east. So regardless of how big amount of rainfall is received in the eastern coastline, you will never have a river moving through the region from east to west across that height and draining into Arabian Sea. No. You will always have the rivers originating from the west draining into east. Some small rivers through the gaps in the western ghats, they might end up emptying into the region of Arabian Sea, but that is an exception. Okay, so here if you will look into it, drainage systems, they represent the flow of water through well-defined channels. Okay, remember river channel that we have discussed? Through well-defined channels, they are known as drainage. And the network of such channels, that is what is known as a drainage system. Okay, now they are governed by the topography of the land, the gradient of the land, geological time scale, how old the rock structure in a particular region is, nature and structure of rocks in a particular area, amount of water flowing, and the periodicity of the flow. How frequent is the water availability in that region going to be? For example, when we talk about the Himalayan rivers, those rivers are referred to as perennial rivers. That is, the flow will be maintained throughout the year. Why? Because in the rivers such as Indus, Ganga, or even the rivers such as, let's suppose, Gandak, Kosi, Brahmaputra, all of them, the flow of the river water is attained how? By the melting of the snow and the glacier. But what about the peninsular region? You don't have any ice or glacier there. So how is the flow going to be maintained? You have huge amount of rainfall in certain concentrated areas. Certain areas receive excessive amount of rainfall in the region of the Western Ghats. That keeps on supplying the water across the entire path. That water keeps on getting supplied by the rainfall. So in the case of the peninsular rivers, can we come to a kind of a simple conclusion that their flow is going to be periodic? In the dry months of the year, they are going to observe limited amount of flow. And in the significant rainy months, there is going to be excess flow. So the drainage system and its characteristic is determined by these variety of factors. Now here, a river, when it drains into an area, it will gather water from all its surroundings, isn't it? If I show you this particular image here, let's suppose, or let me do one thing here. Let's suppose I draw a mountainous region. Let's suppose. Now, let's assume from this area, water is carried, water is brought about, and this is the flow of the water. Let's assume this is the bottom of the foothill. This is where the water is carried. Now, will this water or will this river carry the water only across this channel? What do I mean by that? If suppose there is occurrence of rainfall here, if suppose there is occurrence of rainfall here, all that water which is drained through the streams, they will eventually go and mix with this. In your region itself, wherever you are living, whenever there is rainfall, you would have observed that the nearby river water level increases. Why does that happen? Why is it that the height of the river or the height of the water increases? because it accumulates water from all its surroundings. So the region from where the river accumulates or gets its water, that is what is known as the catchment area of the river flow. So a river drains water collected from a specific area, and that is what is known as the catchment area. What do we mean exactly by this? So let's suppose it is raining here, or it is raining here, or it is raining here, or it is raining here. Let's suppose any of these areas. Wherever it is raining, all that water will get added where? Into that pathway here, isn't it? So this entire region, if it experiences any kind of rainfall, etc., it will add water to the main river. So that entire region, that is known as the catchment area of the river. Catchment. You trap that, or you basically carry the water of that entire area. Then we come across another concept, the concept of watershed. Now here, in drainage systems, when you talk about watershed, that is more or less like a water divide. This is also what is known as a water divide in certain references. So what is a water divide? So if you have a topographical barrier, let's suppose you have a region here like this. Okay. Let's suppose you have a region like this. Now, if it rains in this area, it will form a stream which will flow in this direction. If it rains in this area, let's suppose, this will form a stream which will drain in this direction, isn't it? So as these streams they get created, they move in different directions. Why? Because there is that topographical barrier. Topographical barrier. So such barrier-like structures which separate the water carried by the various river channels, they are known as the watershed or the water divide. Okay. For example, in the Peninsular Plateau, you can say that the Western Ghats, they act as a water divide between the eastern and the westward flowing rivers. You will not have a river which originates generally amongst large rivers unless and until there is a gap in the Western Ghats. You don't generally come across a river which originates in the region of Telangana Plateau and drains into the Arabian Sea. Similarly, you don't have any river which originates on the western side of the Western Ghats and then drains into the Bay of Bengal. No, because Western Ghats forms that topographical barrier. Similarly, if you observe the region of, or if you observe the river basins of Indus and Ganga, in their initial stretches, when they enter India, in their initial stretches, when they enter India, they drain from northeast to southwest direction uniformly. But then Indus continues that motion into Arabian Sea, whereas when you consider Ganga, Ganga moves to the east and drains into Bay of Bengal. Why? You have the entire presence of the Delhi Ridge, etc. But the region of Ambala is where both these river systems, they come very close. And Ambala has got a height above the sea level. That is why it is said that Ambala divide basically distinguishes or divides the flow of Indus and Ganga. So, example, Ambala water divide differentiates, or rather separates, will be a more correct terminology, separates the Indus River system and the Ganga river system. The Ambala water divide does separate them. Okay, so this is where we'll do one thing. We'll end it here. Tomorrow we will start with a sequent and insequent stream. Just I will give you a preliminary introduction in a couple of minutes. When you observe the river movement, rivers will always follow the slope of the land. Rivers will never defy gravity. But sometimes it appears as if they are moving against the slope. For example, when we consider the mighty mountains of the Himalayas, you have the rivers which originate in the region of Trans Himalayas, such as Indus, Satluj, Brahmaputra, Kosi. They originate beyond the Himalayas. Ideally, these rivers should never have been able to cross the Himalayas, but they do. They carve out very deep gorges as they cross the entirety of the region of the Himalayas. How is it possible that a mighty mountain like Himalayas is completely crisscrossed by a river? So, when a river tends to move, sometimes it appears it defies the slope of the land. Majority of the times, as is the case with river Ganga, Yamuna, etc., Godavari, etc., it will always appear that they follow the slope. Some of these rivers, they appear to defy the slope. So based upon that, they are classified into sequent and insequent. Sequent stream, basically, these are the ones which follow the slope of the land. Follow the slope of the land. Insequent stream appear to defy the slope of the land. This is something where we will continue our discussion tomorrow. Ankush, why sands are collected mostly from the rain-fed rivers, not from the snowed rivers? Even from the snowed rivers, you collect sand. Illegal sand mining goes even there. Himalayan rivers also. Basically, that sandy thing that you are talking about, it is on the riverbed. So in the rain-fed rivers, the flow is so less that it is easy to bring out materials from the riverbed. But that alters the flow in the long run. The river basically ends up drying out eventually. In the Himalayan rivers, the flow is maintained throughout the year, so it is very difficult to dry out that river in completion. So there also you have that illegal sand mining which goes on. Backwater point, Ritika. When we talk about the backwater, basically understand that what happens, let's suppose you have here, observe, for example, in this image, the coastal area has got a kind of an elevation, right? So it is not a low-lying land. So seawater will not have the tendency to enter inward. It is the river water which will have a tendency to move into the ocean or the sea. Imagine a condition where the coastal area is having a kind of an absolute lowland, almost to the level of the sea. almost to the level of the sea. Okay. Now, in certain areas, let's suppose if a river is coming from here, this is one of the examples where a river is coming. It is emptying into sea. Now, if the elevation where the river is moving and the elevation of the sea surface both are same, there will be cases where the sea water will enter inland. And when the sea water enters inland, it will inundate and it will flood this entire region. With what? With salty water. It might form various passages where that salty water will go. Here, the sea water has flowed into the land. That is why backward into the land. Hence the name backwaters. Sometimes it can also happen. Again, if the coastal areas is absolutely at the level of the sea, there, let's suppose the sea has entered, formed a large kind of a lake inland. This is generally surrounded by the mangrove population because you have salty water which goes inland. That is a backwater. Is that understood? Okay. So that is where we'll restrict this session here. We meet again tomorrow. Take care of yourself. Goodbye. Thank you.